and warm welcome to you all for the Total Smart Talk series, Lecture 7, Liquid Waste Management in Kerala, Technologies and Challenges, by Dr. RATISH Menon, Professor, Department of Civil Engineering, SCMS College of Engineering and Technology. This is the seventh session series organized by Turtle Smart Solutions as part of our initiatives to provide a knowledge-sharing platform among engineers and academicians through interactions with eminent technocrats from academics and industry. We cordially welcome all enthusiasts to this session in the series organized in connotation with Association of Engineers, Kerala, Thiruvananthapuram District Centre, Indian Concrete Institute, Thiruvananthapuram District Centre, and high-tech total solution providers about a relevant issue, liquid waste management, by an eminent and young engineer who is also an academician and an industry expert in the sector. Association of Engineers Kerala is a non-profit organization of about 4,000 plus engineers from public works, irrigation, and local self-government departments of Government of Kerala. The association encourages research and free discussion on engineering problems we are facing. Hearty congratulations for the Association District Centre, Trivandrum, for associating with us. Now, I request Engineer Anwar Hussain, Chairman, ICI Thiruvananthapuram Centre and Director, High Tech, to deliver a few words about ICI and High Tech.
Good evening, thank you. Indian Concrete Institute is one of the leading professional bodies in India catering to the professional needs of individuals and organizations involved in concrete. Being a non-profit organization, it is dedicated to the cause of disseminating knowledge on concrete to promote concrete technology and construction and to address the research needs of concrete. The ICI was formed the year 1982 with around 500 members from 5 regional centers. Now the membership has risen to nearly 15,000 enrolled members from 46 regional centers in all major cities spread across the entire length and breadth of the country. The 46th regional center was inaugurated earlier this month in Srinagar, and the 47th will be inaugurated in Davangere, Karnataka soon. ICI Thiruvananthapuram Center is situated in the southernmost tip of India, having jurisdiction over Kanyakumari, Thiruvananthapuram, Kollam, and Pathanamthitta districts. High-Tech is one of its kind company in Trivandrum, providing all kinds of solutions for structural rehabilitation and structural retrofitting. We have with us technically sound supervisors and laborers for doing any type of structural strengthening works. We are also doing foundation strengthening works using nanochemicals, polymers, and cement in proportions solely devised by us for various conditions. I congratulate the organizers for arranging this wonderful program. Thanks to Dr. RATISH Menon for handling today's session on liquid waste management in Kerala. I know that this session cannot be limited to Kerala, but has relevance in the whole world. Thank you.
Thank you, Anwar sir. Now I request Mr. Citizen Kareem Andrews, Consultant, Turtle Smart Solutions LLP, and Assistant Professor, Department of Civil Engineering, take its College of Engineering to formally introduce and invite our guest speaker.
Good evening all, I hope I am audible. The speaker for today's session is Dr. RATISH Menon. Dr. RATISH Menon has more than 15 years of experience in environmental engineering consultancy, research, and academics. He has provided technical support to various government and non-government organizations to help them address the environmental challenges. He is involved in the capacity building, developing and delivering training modules for officers of various urban local bodies, industries, and pollution control boards in India. He is also a member of Board of Studies at Kerala Technological University and an initiator of service learning concepts in the curriculum. Dr. RATISH Menon completed his PhD from IIT Bombay and is presently working as professor in the Department of Civil Engineering, SCMS School of Engineering and Technology. He is presently guiding 3 PhD students and has guided several PG students. He has got several reputed publications and funded projects to his account. With all due respect, I invite Dr. RATISH Menon to this session. And before starting the session, let me just remind the participants to keep muted during the session. At the end of the session, we will be having a panel discussion, and we can have the discussion during that time. And if in between, if you have any questions, you can keep the questions in the chat box. Over to you, sir. Thank you.
Thank you, Jitin, and thank you for inviting me for today's lecture. I hope my voice is audible.
Yes, sir. It is audible. It is audible.
Yeah. Okay. Let me open my screen here. Can you see the screen?
Yes, sir. Screen is visible. If possible, can you make the sound a little more louder?
Yeah. Okay.
Yes, sir. It is fine. Thank you.
Yeah. So today's topic of discussion is liquid waste management. As somebody mentioned earlier, it is not only for Kerala, but liquid waste management is a problem for entire India. Now, why Kerala is that among different states, in terms of liquid waste management, Kerala is lacking a lot of things. And a lot of efforts are being put in by the government to bridge that gap and excel in this liquid waste management domain. So it is a good time to have a discussion on liquid waste management technologies, as well as what are the different challenges that we face in the state. And these challenges, some of the challenges will be common, but some may be typical to the Kerala context. So that's the importance of today's topic. And looking at the overview, I would like to split my session into 6 different parts. So first, we will talk a little bit about some terminologies. Some of you may be already knowing some basics of liquid waste treatment and management approaches. So this will be like a refresher kind of thing at that session. Then we'll talk about how Kerala scenario is different, what is happening in the state, and followed by different technologies for wastewater as well as septic treatment. Then we discuss about the challenges in implementing liquid waste management projects in the state, as learned from the previous projects that was being executed in Kerala, like Amrit Kerala and Swachh Bharat Mission. All are working restlessly to implement several liquid waste management projects. So what are the challenges that we are facing while trying to implement this project? And finally, open up our session for a panel discussion on what is the way forward in for the liquid waste management in the state. So that's how I have planned today's lecture. So first, we will go through the liquid waste terminologies and management approaches. So if you look at water, we always talk about water security. You would like to have water 24/7, and but the water is getting scarce day by day. And one of the major reasons for that scarcity is pollution of water sources, and not treating the water that we use becomes the used water. Not doing enough treatment to this used water becomes a major cause of pollution and increases the water scarcity. The availability of good quality water reduces because of the surface pollution. So 70% of the surface water is estimated to be polluted now. Now, as we move forward to another decade, by 2030, the scarcity is going to increase. The amount of water is going to reduce. The availability of good quality water is going to reduce. But at the same time, our lifestyles increase, our urbanization growth, and the demand for the water is going to increase. So there will be a great divide between the supply and demand. Now, looking at the per capita water consumption in the urban area, we are aiming for 135 LPCD, considering different activities like drinking, cooking, bathing, washing of clothes, washing of utensils like that. and we find it very difficult to provide this 135 accuracy in Indian cities. And as we know that once we use this water, whatever water we are getting, 80 to 85% of this water supply become then wastewater. So we talk about supplying water to homes, but we are not very much bothered about collecting it back and treating it and then releasing it to the environment. So, so this 85% of used water is now being left out into the environment, thereby increasing the water pollution and reducing the availability of good quality water. So that's a major concern that we are having. Now, looking at the sources of liquid waste water, when we say liquid waste, we mainly talk about the domestic water, wastewater that we are receiving from cities. So, depending on the nature or the characteristics of this used water, we divide it into different color coding systems. So we have major categories: the black water and the gray water. Doesn't have anything to do with the color of the water, but it is color coded to indicate the content of the water. So black water means the water that contains fecal matter. So the water that is coming out from the toilets or urinals are called black water, and gray water is the water that comes from different activities which does not contain fecal matter. For example, kitchen, from the kitchen or from the bath, laundry, etc. Now, black water combined with gray water, we use the term called sewage. So that's a general classification of used water. Now, so domestic sewage has both gray water as well as black water, and another term we should know is fecal sludge. So when the human excreta is containing in a pit, and the sludge that we store or accumulate in a pit is called fecal sludge. It has a very high solid content compared to wastewater, and because the water content is lesser in the fecal sludge, and it is relatively fresh and the color is yellow and it has low dewaterability, but it has higher BOD. So BOD is a term that we generally use to indicate the strength of the wastewater. It is the amount of oxygen that is needed for the microorganisms to degrade the organic components in the wastewater. So higher oxygen demand means higher strength of the waste. So fecal sludge has higher BOD compared to sewage, and therefore it needs high degree of treatment before being released into the environment. So if we are releasing a high BOD waste into a water body, for example, what will happen is the microorganism will start decaying that organic matter, and for that they will be consuming dissolved oxygen in the water. So if the dissolved oxygen is consumed, then it creates an anoxic condition, an anaerobic condition within the water body, and that can cause problem to aquatic species. Aquatic animals may die out because of that. So we can't just let this fecal sludge or sewage dispose directly without any treatment. Now, another term that we use is septage. Now, septage and fecal sludge are different in a way that the septage, they both have high strength waste. It has high solid content, but septage is well digested than the fecal sludge. It is the sludge that we take out from the septic tanks. Now, I will talk more about septic tanks in the later slide. So septic tank is a system commonly used in Kerala for treating domestic wastewater. So the black water from the toilets are contained in the septic tank, which is basically an anaerobic biological reactor, and in that the organic matter gets well digested. Now the digestion is only about 50 to 60%, and the remaining sludge needs to be taken out after 2 or 3 years, because the undigested part will start filling up the septic tank, thereby reducing its efficiency. So we need to empty the septic tank once in a while, like within 2 to 3 years, we have to remove it. And then this cannot be left out without any treatment, because there are still a 40% of organic matter that is not digested. So we have to have another treatment for that. But the sludge that we take out from the septic tank, we call it as septage. And it has high solid content. It has lower BOD compared to fecal sludge, because it has already got digested inside the septic tank. So it needs lower degree of treatment compared to fecal sludge. Now, looking at when we say used water or wastewater, what are the different constituents of the wastewater? So the wastewater contains organic matter, which is biodegradable. That means we can use microorganisms can act upon this organic matter and stabilize them. Then we have inorganic matter, inert materials. We have nutrients, nitrogen, phosphorus, and potassium. Then we have chemicals, recent developments in the bathroom cleaners and now contribute a lot of chemicals into the wastewater or sewage. So we have some chemicals and we have pathogens. Pathogens are the microorganisms that can cause diseases in human beings. Now, looking at liquid waste characteristics, so we mentioned about fecal sludge, septage, and sewage. So looking at the major parameter called COD or BOD, it will be very high for fecal sludge, then septage, and then sewage. Sewage will be a little more diluted because it has more water content. Then total solids also very high for fecal sludge, comparatively lower for septage, and lower for sewage. So that means the treatment that we do for septage and fecal sludge is different from the treatment that we do for sewage. Now, what happens when we are releasing this wastewater into the environment without any treatment? So there are two impacts. One is impact on the environment, and another one is on the public health. So when we release it into the environment, it pollutes the surface as well as groundwater. So contamination of the fresh water results in. Then there is biodiversity threat, and it affects the ecology, especially aquatic ecology. Then it affects socioeconomic and cultural aspects of the project area. Like, for example, nobody would like to live very near to a dirty canal or a dirty pond. So socioeconomically, and so the land prices may fall, and maybe poor people will they have no other choice but to live very near to this polluted water body, which in turn affect their health. And some public nuisance also, then mosquitoes, fly, all things will cause nuisance because of the pollution of water body. Then health impacts include exposure to harmful microorganisms. So polluted water may contain a lot of pathogens like cholera, diarrhea, tuberculosis, etc. And it will have also have worms which stunt the growth in kids. So stunting growth has been recently observed, and the major reason for that is the wastewater contamination of drinking water. So one thing we have to understand that the money that is being spent on treating liquid waste or wastewater is justifiable, because when we treat the wastewater, we are actually helping improvement in the public health. So otherwise, if we do not spend money on treating the wastewater and leaving it to the environment, we may have to spend more money on public health than what we have to spend on treating the liquid waste. So that's a justification for at least treating the wastewater. It improves the public health. People can live in a good environment, and they will be less impacted by pathogenic microorganisms that would otherwise come in contact with the water. Now, looking at different wastewater systems. So, how do we treat the wastewater? What are the different steps in treatment of wastewater? So, first one is user interface. So, user interface means the toilet where people produce the waste. From the toilet, it has to be like transported, and then it has to be treated. And after treatment, normally it is disposed, or if there is a reuse value, we have to go for reuse. This is the general approach. Now, there are different wastewater systems. The first one is a centralized system. In a centralized system, what happens is the entire city is the different houses in the city are connected using pipes called sewers, and these pipes conveys wastewater from the home to a treatment plant. So there will be only one single and big treatment plant. So that's called centralized system. All the houses will be connected to this sewerage. So the sewer network is called sewerage, and the wastewater from individual homes will be connected through this sewerage, and this sewer pipelines will take the wastewater to a centralized treatment plant. And there it will be treated, and the water, after treatment, may be reused or disposed properly. So this is a centralized system. Another one is decentralized treatment system, where the waste from homes will be taken to a treatment plant. So treatment plant will be smaller in size, and the entire city may be divided into several zones, and each zone will be served by a different sewer network. So there will be a simplified sewer network for different regions, and there will be more than one treatment plants of smaller capacity, and the processes may be same. Water will be treated and disposed or reused, but the capacity of the plant will be smaller, and also the coverage of the sewerage system will be divided into different zones, and they will be serving different zones. Then the last one is the on-site sanitation of fecal sludge management system, and in Kerala context, it has a very high importance, because most of the houses in Kerala use this on-site sanitation system called septic tank. So from the household toilets, the wastewater first goes into a septic tank, where it gets decomposed partially by anaerobic treatment. The microbes that grow in the absence of oxygen will be working to decay the organic matter in the wastewater. And after that, once the septic tank sludge fills up, it has to be emptied and transported for a treatment plant. So the treatment plant where this septage, the sludge that we take out from the septic tank is treated, we call it as fecal sludge treatment plant, FST. Now, after the treatment, the fecal sludge may be used as a fertilizer or a manure, and the water may be treated and reused or disposed. So these are the different wastewater systems that we adopt in different cities. So again, representation of a centralized system. So here you can see that all the houses are connected to a main line through which the wastewater reaches a centralized treatment plant, and there after treatment it is disposed in here it is disposed into a river. When it is decentralized, the entire city will be divided into different zones, and we will have more than one treatment plant within the city, and different houses will be connected to different treatment plant depending on the urban plan. And in the on-site sanitation approach, this is called the sanitation value chain. So we have capture or the interface first, that is a toilet, and then we have containment system. So popularly we use septic tank system, and then after septic tank gets filled in with digested sludge, it has to be emptied, and emptied then it is transported in trucks to a treatment plant which is called FSTP. And in that treatment plant, you process this sludge or the septage, convert it into a fertilizer, and reuse that for agriculture purpose, and you grow food. So actually, this is called a sanitation cycle. So the waste is now converted into a agricultural produce. So thereby actually completing the cycle. So this completion of the sanitation cycle is very important to maintain the balance in the environment. So if any of the steps fail, then we have a serious problem. So we have to have the toilets, that is a must, and we have accomplished a lot in that aspect. Kerala is a state with maximum number of households having toilets. All of the new houses have toilets built in. So that capture part is well handled in Kerala. And to some extent, the containment part is also well handled. Most of the houses have septic tanks, even though some of the houses are having only pit latrines, which is actually not good, considering the fact that this the percolation from the pit latrine can contaminate the groundwater. So, but mostly everybody go for the septic tanks. So the containment part is also handled. But what is not handled is this emptying. Emptying transport is also there. There's an unorganized sector that is working in emptying and transporting of the septic, but they then throw it out somewhere into environment, like on water bodies or open land, because we have not provided them with enough treatment facilities. So FSTPs are what we are lacking to complete this sanitation cycle. So FSTPs have to come in, and once they are in place, the septage can be well treated in the FSTPs, and then the product, treated products can then be used for agricultural purpose, thereby producing agricultural produce and then completing the sanitation cycle. So these are the different approaches. Now, if you ask which approach is better, so there is no single answer to it, because it depends on a lot of factors like local conditions, needs, cost, and time frame determine the choice of the approach. So in some cities, a centralized approach may be well suited. but for many other cities, decentralized approach may be good. And in many other cities, on-site sanitation system may be a good approach to go. So it's not that like one approach is better than the other. It is depending on the local conditions, cost, and other parameters, you have to go for a particular approach. Ideally, in a city, what we really need is an integrated approach. So you may see that the core sanitation zone, the inner core of the cities, where there are a lot of buildings nearby, highly populated section, that's for core sanitation zone. There, providing a sewer network may be a good approach. Providing a sewer network and carrying the wastewater to the outer periphery of the city and then treating it and disposing it may be a good idea. But for the outer part of the city, beyond the core sanitation zone, it would be a good idea to provide decentralized systems, because they are scattered, the population is scattered, and connecting all of them together may not be feasible. So ideally, we will provide small treatment plants in this area, and we go for decentralized wastewater treatment approach. And for other places where there's already on-site sanitation systems in place, like septic tank facilities available, for them we provide this FSM or the treatment plan FSTP. So we carry the sludge and take it into FSTP and change it. So for the same city, we may need more than one approach, and that is why we call that an integrated thinking is required to solve the sanitation needs. Now coming over to second part of the talk, Kerala scenario. So within Kerala, if you see, the treated sewage is very less. So only 3% of the total generated sewage is scientifically treated in Kerala. And this is what we are trying to improve. So if the sewage generated is around 4,000 MLD, out of that only 120 MLD is the installed treatment capacity. And if you see the cities with the sewer network, there are very few cities that have sewer network coverage. Trivandrum is one of the cities that have 30% or so coverage. Kochi has a little bit of coverage, but other than these two cities, we do not have much sewer connected sewer network coverage in cities, and that is a big problem because all these cities are highly populated. Now creating a sewer network at this point in time may be very difficult, because it includes excavation and pipe laying, and the roads are very small and not wide enough for conducting all these activities, so that it becomes very challenging to implement a sewer network in cities of Kerala. So what we see here is 98.8% of households have latrine facilities. They have toilets, but only 4.7% is connected to sewer system. So that means most of them are using on-site sanitation, or they are directly throwing it into the environment. So that's the main issue. And under the initiative of Shujitva Mission, there was a campaign to look at the quality of water in canals, ponds, and rivers in the state. And the results were very astonishing results, because 80% of the water bodies were found to contain coliform bacteria. And now the coliform, as we know, is the bacteria that grows inside our intestine column. and their presence in the drinking water means that fecal matter has been in contact with the drinking water. Now, why it is happening? It is happening because of the in the previous slide I showed you, around 98% of houses have toilets, but the sewerage network is very small. So what is happening is this wastewater is being left out into environment, and we see that in major water bodies of Kerala. The streams that used to flow very beautifully are now contaminated, and in Alapura and all, you see that the water hyacinth is a problem because the water hyacinth is getting a lot of nutrients coming into these canals, and the nutrients are nothing but wastewater. And major water bodies, major canals, people are actually throwing out their effluent directly into the urban water body, so thereby contaminating the water as well as destroying or degrading the water body, which is not that good considering the tourism value of the state. And this needs a serious consideration on improving the wastewater treatment scenario. Now, looking at the existing on-site sanitation systems, one of the major issue is in constructing proper septic tank. Most of the time, people say that they have septic tanks, but these septic tanks are not really septic. What I mean is that this septic tank has to be actually airtight, because there should not be any oxygen inside. The bacteria that grow inside the septic tank are anaerobic bacteria, which grows in the absence of oxygen. So, and they take around 48 hours or so to decompose this waste. So we have to hold the water for that long inside this tank, and this water is be allowed to flow out of the system only after 48 hours. So if there are cracks, or if the bottom is not lined properly, there will be chances that the wastewater before treatment will percolate downward and reach the groundwater, contaminating the groundwater. And the construction, if it is not properly lined, it can cause infiltration, and also there can be cracks which prevent the condition to be septic. So the oxygen can get inside, and the bacterial action will slow down, and it will not work as intended. You see a septic tank system. So normally we must use at least 2 compartment septic tank for better solid retention. So what we do is, when the wastewater comes into the septic tank, we provide a holding facility, that is basically the septic tank system, and there we allow the solids to settle in, and the solids settle to the bottom, and the effluent is then going into a stock pit. And inside the septic tank, bacterial actions will be happening, and this sludge will be treated. Around 50-60% treatment happens, but still there will be sludge buildup. So after 2-3 years, what happens is the septic tank will be full with this partially digested septic. Now, once it fills up this tank, the water holding capacity of the septic tank system reduces. So instead of 2 days of hydraulic retention time, now what happens is it may bypass the flow, because there is no volume to contain the water for 2 days. So the efficiency will be decreasing. So it's very important that the septic tanks are emptied once in 2 or 3 years to improve their efficiency. Otherwise, septic tank will not be functioning as it is designed for. Then also, if there are cracks And if this effluent, which is normally after septic tank, what we provide is a stock pit. A stock pit is nothing but an infiltration pit, and the wastewater that percolates to the ground is acted upon by the microorganism in the soil, and these microorganism decomposes the remaining organic matter, and it treats the water before it reaches the groundwater table. But in some cities like Alappuzha, Kochi, they have a very high water table. So the soft pit system may not work, and soft pit may actually become a reason for contamination of groundwater. So the soft pit system works only when your water table is far below. So then you get enough time for the wastewater to get filtered through the soil, and the microorganisms can decompose the remaining organics. So the current situation here is lack of proper septic tanks at the household level. There are some of them are called septic tanks, but they are not septic tanks. So there are IS standards available for the construction of septic tanks. IS codes are there. Then lack of adequate treatment plan for the septic is a major issue. Then lack of systematic transportation and treatment, collection and conveyance. With the collection in some places, we see that they collect the septic and then throw it out in the field. So it is as good as defecating in the open. So when we say open defecation free, we are not actually open defecation free, because unless we are treating the septic, otherwise the septic will be thrown out into the environment and it will have the same impact as open defecation. So this is a technique we use to visualize a city's sanitation, how properly it is working. This is called sheet flow diagram, and this one is for particularly for Kochi. This has to be created for Kochi, and we see that here 78% comes from the wastewater, comes from on-site sanitation. 22% is coming from the off-site sanitation, and from the off-site sanitation, only 20% is being treated actually, and 80% of the wastewater generated in Kochi is unsafely managed. So that's the status that we have right now, and this is what government is trying to improve. This situation has to be improved. Now let's look at the technologies for wastewater treatment. So whatever may be the treatment mechanism, use either physical or chemical or biological methods. So mostly when we deal with the domestic sewage, which has high organic content, we go for biological methods, because biological methods are cheaper and also very effective in treating organically degradable waste. And the objective of the treatment, the high priority would be to make the water pathogen free. So whenever we are disposing this treated wastewater, it should be pathogen free. Organic load should be reduced. If we are not reducing the organic load, as I mentioned earlier, when we dump this wastewater into an urban water body or a lake or river, immediately the microorganisms will start consuming oxygen from the water body, thereby reducing dissolved oxygen and killing aquatic animals. And acidic conditions may set in that water body, and it will fill the water body. So organic load has to be reduced. So now, depending on how much has to be reduced, we have to select the treatment technology. For example, if my initial BOD is 100 and my discharge standards are 10, I have to remove the 90, right? But if my initial is 250 and I have to bring it to 10, then I have a lot to reduce. So my processes will be different because I have to come down from 250 to 10 instead of 100 to 10. And if it is my initial is only 50, then the process will be different. So the disposal standards are already set in by the pollution control codes. So independent of what is your incoming waste trend, you have to obey the disposal standards. So based on that difference, we have to bring in the treatment process. Now, ultimately, reuse is an option, but very rarely that we see that we use this treated sewage water. But in many states, they are using it for agricultural purposes and for non-drinking purposes. In many cities like Singapore, they have started to reuse this treated sewage to an extent that it is drinkable. So they are actually selling drinking water out of treated wastewater. But that kind of situation has not reached in India yet. But we will have no other choice in future but to treat the wastewater to drinking water standard because of the increasing scarcity in water. Now, looking at the sewage treatment technologies, majorly we use electromechanical or conventional treatment system. Then, if the wastewater quantity is small, we can go for natural-based treatment also. It has its own merit and demerits. We will discuss that. So, and then the post-treatment methods like tertiary treatment RO, where the wastewater can be then passed through a membrane to make it good enough for drinking purpose. So the conventional electromechanical treatment system. So whatever may be the wastewater treatment technology, you will see that these steps are in every treatment plant. These 4 steps are there. So first one is the primary treatment, where you remove, you do the screening and you remove the solids. You do the primary sedimentation to reduce the BOD load onto your treatment plant. Because if you can settle out the solids, you can reduce the BOD a lot. Because then these settled solids can be, the sludge can be taken out and treated. So this will reduce the load on the treatment system and the secondary and tertiary steps. So primary treatment is there. Then the major component of a treatment plant is a secondary treatment system, and that is where we do the biological. It's actually a biological reactor. We grow microorganisms there, and most of the electromechanical sewage treatment plants are utilizing aerobic condition. So we have to supply oxygen 24/7, and aerobic microorganisms will be growing in this secondary treatment tank. And depending on how these microorganisms are growing inside the tank, how they are nurtured in the tank, there are a number of different technologies. So secondary treatment, the basic treatment that we do is we allow the microorganism, aerobic microorganisms to grow inside, and we provide oxygen that is required to decompose the coming waste. Whatever may be the strength, if the waste strength is more, that means we have to provide more oxygen. So the waste has to be held in the tank for a more time period. Then after the secondary treatment, the microorganisms utilize the organics as their food, and they grow, and they will become large biomass. Floats will happen, and then these floats are then settled out in the next stage, which is called tertiary treatment. So basically a clarifier will be there, a sedimentation tank will be there, where we are settling in the increased bioflow and removing it as well. Then from there, the supernatant liquid will go into a post-treatment. Normally we use sand filtration and carbon filtration, and also disinfection. Disinfection is done to remove all the microorganisms that could be pathogens. So we have to kill all those pathogens, and this process we use chlorine gas or some other disinfectant like ozone, or maybe sometimes we use ultraviolet for disinfection. And after disinfection, this is then disposed of, reused. Now, depending on the secondary biological reactor, this secondary treatment, there are many different processes that we use. So the microorganisms can be either suspended inside the water and inside the tank, or it could be attached onto a surface. Now, if it is suspended, there are many techniques which use suspended growth process. This is called activated sludge, is the popular method, ASP. Then there is sequencing batch reactor, which is nothing but the processes are same. Only thing is that it uses only one tank, where extended aeration is and settling, everything happens in one tank. Then there is membrane bioreactor, where microorganisms are grown, like in activated sludge process, and then using a membrane, we filter out the wastewater. So the water, once it passes through the membrane, it will be much clearer than conventional system. So membrane bioreactor helps to avoid a secondary or tertiary system or secondary clarifier. It allows, we don't need a secondary clarifier, which is the tertiary treatment system, if we are using membrane bioreactor. Then there is an anaerobic process that is used to treat very high strength waste, especially from food industries and all. It's called upflow anaerobic sludge blanket. So completely anaerobic process, but fluidized bed is there. And the microorganisms are suspended in the liquid. Then attached growth processes are there, where microorganisms are growing on the surface of some medium and as a biofilm. And these microorganisms remain on the surface, so they can get more contact than the suspended system, and the treatment efficiency may improve. So one of the very popular attached growth process is moving bed biofilm reactor, MBBR. RBC is there, rotating biological contactor, and fixed filter. They are old systems, but MBBR is more popularly used these days. And there we have a media. So in the MBBR system, you have media like this rings, and the microorganisms grow on the surface of this ring. And this media will be moving inside the reactor under the influence of aeration. So bacteria is moving, but at the same time they are growing on the surface of this media. So this is a bit more efficient than the conventional ASP. Then membrane bioreactor is another technology. It's very compact and high treated water quality is possible. We can have a high volumetric load also possible. Conventional ASP can be upgraded using this membrane bioreactor. Advantage is no secondary clarification is needed because the water is already passing through the membrane, so we don't need to again have a settling tank where to remove the solids. The disadvantages are higher capital cost. Operation and maintenance cost is 20% higher than the ASP. And there can be some issues like membrane fouling, because organic matter, when it passes through the membrane, it gets attached on the surface of the membrane and it creates membrane fouling. So you will have a need, the cost of operation and maintenance may get higher. Then another treatment system for sewage is the nature-based treatment system, where we fully depend on a wetland, a constructed wetland, and we are actually mimicking what happens in the nature. So when the wastewater is let out into the nature, what happens to it? A part of it may percolate through the root zones of the plants, and the plant will pick up the nutrients, and also the microorganisms that grow in the root zone will decompose the organic matter, thereby reducing the strength. So this natural process is actually unique in the nature-based treatment system. There are many different nature-based treatment systems like horizontal flow, vertical flow, constructed with land. So here in this diagram, we see a horizontal flow system where the sewage is first let into a settling tank, which is usually an anaerobic reactor or a septic tank, so a big septic tank. And from there, the effluent is allowed to pass through a horizontal gravel bed, and the plants are allowed to grow on this gravel bed. So when the wastewater passes through the root zone, the microorganisms within this gravel bed, biofilms, the microorganisms grow as a biofilm on the surface of this gravel, and they decompose the organic. And plants, what they do is they take up nutrients like nitrates or phosphates, and they grow. So the water, once it reaches the end of this gravel bed, it would be very it would be better than what it was at the entrance. So the treated wastewater is then allowed to percolate into the ground, or it is used for irrigation purposes. The advantage is that you don't have to use a lot of energy. In electromechanical system, you need to provide aeration 24/7. This increases the electricity cost. But here you don't require that much aeration because this is a natural system. There are limitations because it needs a lot of area, a land area is needed. Another thing is it may cause nuisance in the surrounding, it may cause some smells if it's not properly working. So these things are a problem. But for small communities, apartments, this is a very doable thing. And it will also look very nice in terms of the landscaping features. So we can design this as a landscaping feature in that community. So these are some images of such systems being implemented at different places. Now look, comparing average cost and land requirement of nature-based and electromechanical systems. The nature-based systems are represented by the blue histograms, and red ones are electromechanical systems. So we see that as the STP capacity is increasing, in the left graph you see, STP capacity when it increases, the cost of electromechanical systems shoots up. So when you have large amount of wastewater is coming, natural-based solutions will be much cheaper compared to electromechanical systems. But at the same time, the land requirement, if you see, the land requirement will be very high for nature-based systems. So you have to make compromise. Depending on your situation, you will have to select whether to go for a natural-based solution or for an electromechanical system. Electromechanical system may be costly, but it may get lesser land. Then for one MLD plant, if we compare different technologies, sewage treatment technologies, we'll see that membrane bioreactors have a higher amount for compared to other systems. But the land requirement wise, if you see activated sludge process require more land than the membrane bioreactor. So this is a comparison of cost as well as land requirement for different technologies for a 1 MLD million liters per day plant. Now coming on to, so far we have been discussing about sewage treatment. Now looking at septage treatment. In the septage treatment, it is a little bit different from sewage treatment in a sense that it has high solid content in the septage. So these are the stages that we follow in septage treatment. First one is solid liquid separation. We have to remove the solids and we have to separate out the liquid from the solid. The solid is treated in a different way, and the liquid is treated as a liquid as we treat the sewage. Solid separated and it is stabilized, dewatered, and we reduce the pathogens, and then it is made into compost or fertilizer, so that it can be used as an agricultural. It can be used for agriculture. Now, in solid liquid separation, you can have a physical treatment, like you can have a settling time, thickening pond, like that. Then in the stabilization, you can have biological treatment like a digester or anaerobic reactor, where this substrate is again allowed to get digested anaerobically. It is already digested up to 50% or 50%, but it is again then try to digest again to reduce the organic solids. Then dewatering is done. Dewatering can be either done using a planted drying bed, or mechanical drying can be done. Then pathogen reduction is done. So pathogen reduction is the one of the techniques for pathogen reduction is to starve the microorganisms. So we keep these solids, the dried sludge, for a longer time, so that the microorganisms all die off. Or you can disinfect, or you can incinerate this sludge to make it into biochar. Then this can be then utilized for agriculture as different end products, and either as dried sludge or biogas or compost, like that. So one of the very simple technique of sludge treatment is deep road trenching. It is not advisable in places where we have a higher water table, because there is a high chance of groundwater contamination. But it is simple in operation. It is used when the quantity of septage is very small, like 3 KLD only. Large area is needed, and if you see in Kerala, it will be very difficult to do this kind of septage treatment. But if a house has a lot of land, then they can do their septage treatment in their yard. That is possible. Then another one is the geobags. Geobags are membrane bags where you fill in the septage, and these bags, once it is full, under pressure, it will bleed. It will then, the water will escape through the pores of the membrane, and the solid will be retained inside the bags, and we will keep it for 3 months for drying. And after that, this will be taken out, the bag, the solids will be taken out and used as a manure. So this is the geobag technique for septage treatment. And natural based treatment is called planted drying beds. Planted drying beds is nothing but similar to a constructed wetland system. Where we have an cable bed over which the plants are growing. Sludge or the fecal sludge or septage is then introduced on top of this gravel bed. What happens is the water will percolate and the water will be taken out for treatment, and this sludge will be retained at the top of this gravel bed, and it will remain there for 18 months or so, degrade, dehydrate, and become a compost. So like this. So loading phase, you will see that the septage is actually open to atmosphere. So there can be nuisance, fly nuisance or smell or mosquito breeding in this situation. So it is not advisable to keep this kind of plant in a highly populated area. But if you have if it is a rural area and you have a lot of land, this is a very simple method, and is also cost effective. Now, mechanical dewatering system. So once we go for mechanical systems, obviously capital cost will increase, and also operational cost and maintenance cost increases. But the advantage is that it is an enclosed system. It will control odor and moisture. Land availability is not a constraint in this. but it will require high electricity. So this is a centrifugation machine where the sludge is introduced, and then after centrifugation, the solids, dried solids will be taken out, and the water will be taken for treatment. Then another one is the belt filter press, where the septic is allowed to pass through the filter, and it has good dewatering capacity. It's very difficult to control odor because it's an open system. There will be odor in the plant. Then skills are required because maintenance, there are a lot of moving parts, so maintenance costs will be high, capital cost also high. And after dewatering, the sludge needs further treatment. Another method of sludge treatment is pyrolysis. So in Kerala-like conditions, when we have rain for at least 6-7 months and also high humidity, it may be difficult to have a drying bed. So after dewatering, we can do the thermal drying and then do the pyrolysis to create biochar. And this biochar has good fertilizer value. So it will, this kind of plant will have lesser footprint, independent of weather. There will be less public protest because of the smell and other things. And the handling of treated sludge is also easy because the sludge now comes as biochar. Disadvantages, of course, capex, opex costs are high. Skilled labor is needed, and because pyrolysis is happening, air pollution chances are there, so air pollution control devices have to be implemented. And for a similar plant in Warangal, what they have done, they have implemented a 15 KLD plant. The cost was around 2.1 crores. That shows how expensive it is. Then there's mobile treatment unit. Many of you must have seen it. It was developed by Wash Institute. It is a very small treatment unit mounted on a vehicle. This can go to home and clean the septic right there at the house itself. So it's a domestic level decentralization in septic treatment. What they do is solid liquid separation using a membrane filter. And after that, the liquid is again treated in membrane. Sludge thickening is done using a centrifuge because the quantities are very small. The machineries are compact in size. Treated effluent meets the standards of PPPB, so that's not an issue. Now, we have discussed sewage treatment technologies, septic treatment technologies. Now let's look at what are the challenges in implementing the projects. So we should know that there is no best technology, so as to say. The technology, you have to select always best appropriate technology. One technology may be very feasible in a particular city, it may not be feasible in another city. So depending on the different parameters, we have to select the technology. So these are the list of parameters that we have to consider while selecting a technology. So influent characteristics, climate constraint, cost, performance, complexity of operation, then chemical requirement, energy requirement, land availability, what we do with the treated residual, or how we will dispose the treated wastewater. All this matters in selecting the technology. So it's a multi-parameter selection criteria. Now, when we look at the Amrit scheme, there are two schemes. Two schemes are there, ongoing schemes are there. One is Amrit. There are 9 cities which falls under Amrit scheme, where the focus is on creating STPs as well as FSTPs. So we see that in these 9 cities, a total 5 number of septic treatment plants and 10 number of e-waste treatment plants were proposed. But so far, we could only complete 2 STPs. So still a lot of work needs to be done to satisfy this proposed capacity, like 27.75 MLD is proposed capacity for STPs, 0.32 MLD is the proposed capacity for FSTPs. So far only 2 STPs have come up, and remaining cities are working hard to achieve this target. In SBM, you see nothing have been implemented so far, but DPR preparation is underway, and total 36 MLD STP capacity is proposed. If it comes in, it will serve a lot of population and improve the current scenario in Kerala. So major challenges in implementing. So right now Amrit 2 is ongoing, but there were a lot of issues in Amrit 1. Seems it was very difficult to complete the projects because of a lot of these challenges. One thing is, of course, rapid urbanization is creating a lot of liquid waste is generated. Connecting everything together is very difficult. We have to give more focus on on-site sanitation system. So the thrust is always thrust has always been like 70% thrust is for FSTP and 30% thrust is for STPs. But the land availability is a big issue in Kerala. Another major factor is this lack of public support, not in my backyard approach, where nobody wants to, everybody understands that the liquid waste has to be managed, but nobody wants to keep the treatment plant near to their house. It is to some extent it could be because of lack of awareness on wastewater management, so that is another challenge that needs to be resolved. Then ULBs are they need technical support in selecting appropriate technologies for their conditions, especially while preparing the DPRs. The ULBs are having a very difficult situation to understand different technologies. They compare their efficiencies, and so normally a consultant will be preparing a DPR, and they really need technical support to understand or vet these proposals. Then funds as well as skills for operation and maintenance. ULBs need their own funds to maintain, and also to operate. Really skillful operators are needed. So there is a huge gap in the skilled labor available for STP operation. So there needs to be some way of bridging that gap and increasing the capacity or the skills of operators, because a skillful operator can reduce the cost of operation in the STP. And if the operator is not highly skilled, there can be many issues that can come in the treatment plants. Now, what is the way forward? So that is something we need to discuss after this session. But I have written down some points. This is not an ultimate list, but this is open for discussion. So we have to have an integrated planning for cities. Some places we have to go for centralized system. Sometimes we have to go for decentralized system. And wherever it is possible, we can go for natural-based treatment systems. At least at the institute level, for a hospital or a apartment complex, we can push for the natural-based treatment system. Then for space is constrained, go for a compact electromechanically operated system. Then promote fecal sludge and septic management in Kerala, because most of the houses are using OSS septic tanks, and FSTP is must for treating the septic waste. An adequate provision for O&M has to be provided at the planning stage itself. Then monitoring of these treatment facilities. There should be a clear system. If we are using this on-site sanitation approach, there should be a clear system for monitoring the conveyance, emptying, and also the treatment plant operations. So that needs to be given importance. Then social and awareness generation consideration. People have to visit the best practices. So most of the time, people lack trust on the technology or the implementing agency. So they need to see the completed project to understand how it works. Then mass IEC campaign may be needed. It has to, these proposals, the DPR has to come from the grassroots level. If we have to involve the residents and community in the planning process itself, rather than we encounter them during the construction phase. Then capacity building of the key stakeholders is especially for the selection of appropriate technologies, a major thing to do. Then there should also be a mechanism to handle the public grievances. I acknowledge Water Institute, Kerala, Famous Water Institute for the content of these presentations. So with that, I would like to wind up my session and have thank you.
Thank you, sir. That was a wonderful presentation from Dr. Ratish Menon. Now we can start the panel discussion. And before starting the session, let me just introduce the moderator. Engineer Ajit Kumar GS, an eminent practicing engineer who has more than 30 years of experience in the construction field. And he has also decked positions like Project Director, Project Management Unit, Rebuild Kerala Initiative, Superintending Engineer PMGSY, Superintending Engineer Thiruvananthapuram Corporation. And he has also a vast experience in this field and many of the construction field. He will be the moderator for the session. Welcome, sir. And now we just introduce the panel members. First, we have Engineer Sandeep KG, the Chief Engineer of LID and EW, who is an engineer with vision who leads an engineering wing of around 4,000 plus engineering staff. He takes immense efforts in the implementation of waste management projects in the Kerala local bodies in association with Sujitva Mission. We also have Engineer Praveen KS, who is the Director, Sujitva Mission and Deputy Chief Engineer of KWA, who has more than 25 years of experience in water and wastewater sector, including experience in academic research and industrial R&D. He is also author of more than 15 publications. We also have Engineer Anwar Hussain, who is the director of the firm High Tech Total Solution Providers and chairman of ICI. We also have two professors from Bangalore, Professor Ramraju and Dr. Jyoti Rupa. Dr. Ramraju is presently working as a professor and head Department of Civil Engineering, Dayananda Sagar College of Engineering, Bangalore. And Dr. Jyoti Rupa is presently working as associate professor in the Department of Civil Engineering, MS Ramaiah Institute of Technology, Bangalore. We welcome all the dignitaries, and I hand over the session to the moderator, Engineer Ajit sir. Thank you.
Thank you. Thank you, Jitin sir. Thank you, Ratish sir, for a wonderful presentation. Sandeep sir, LSGA is going to take a lot of projects in liquid waste management. What are the challenges that LSGA is facing? Will you please share your experience?
Adit sir, you are not audible. Can you please repeat what you said?
LSGI is going to implement a lot of liquid waste management projects. Sandeep sir, what are the challenges that LSGA institutions are facing? Will you please explain with your experience? Okay.
I think we are not able to hear from Sandeep sir. Hello, sir.
Sandeep sir, can you hear us?
I said, Sandeep,
Hello sir.
I think Sandeep sir is having a connection problem.
Yes.
Can we move to the next person? Then we'll come
Yeah,
back to
yes,
Sandeep
yes,
sir.
yes, sir. Praveen sir, Shujitva Mission is actually a supporting mechanism to implement liquid waste management projects. What are the strategies and plans that you have to get good results from LSDA institutions?
Actually, I will say that you may all aware from the concept that is presented that the liquid waste management, the concept is very simple, but the design is complex and the execution needs very special care. That is a basic technological challenge which we are facing, because simple in the sense it is basically based on physics, chemistry, and biology. That Dr. Ratish Menon sir has already pointed out using 3 circles. Actually, the wastewater treatment methodologies you can all sum up with the principles of physics, chemistry, and biology. It is so simple. But the design is so complex in the sense that we are designing the process with a living organism. Basically, all the engineering designs are using non-living things like maybe we'll use cement, stone, all these things. But here we are using a live organism. The performance and efficiency of the process all depends on how well you can manage this living organism, which is a microbe, which you cannot see even with your naked eye. So that is the complexity of the design. And the special care you need during execution is because it consists of civil engineering, electrical engineering, mechanical engineering. All the principles are involved in the execution. So unless you take care of all these things, the technology is not going to yield the result you are expecting. That is the biggest challenge. Now that the local bodies are not equipped with such a kind of mechanism, what Shujitva Mission is doing is that to ease out the process, we are following certain mechanisms. One is that we'll be adopting, as Dr. Ratish Menon has pointed out, for small capacity, we'll be adopting packaged treatment plants. That is our proposal. So for less than 50 KLD, maybe for institutional sewage treatment plants and ETPs, we'll be following the packaged systems. Basically, it will be electromechanical components. So then for the FSTPs, that is PK sludge or septage treatment plants, we'll be empaneling agencies, will be issuing standard guidelines and templates of design, plus some design, not in the strict sense, but some flow charts, some process flow. We'll be sticking to some standard procedures which is adopted across India, because there are a lot of plans which are proven successful. So such technologies will be enlisting and we'll be empaneling agencies using that technology. So that will be restricted. We'll be giving enough scope for the transparency and openness of the technology, but we will restrict that it should be proven in India somewhere. So that gives the LSGD some kind of a mechanism by which they can select from these selected agencies only, and they will bid for that. That standard bidding documents, all these things will be providing. And only for the big STPs with network, we'll be going for a detailed DPR and based on that tender. And the approach what we are following is basically the central government approach of SBM mandates that in the rural area there should be FSTP plus grey water management, and the urban area there should be STP with co-treatment and grey water management. So this will be, in principle, we'll be following these general guidelines and be providing maximum help to the LSGD so that they will not, their work will be very much minimized. This is what we intend to do. Thank you.
Thank you, sir. Thank you, sir. Anwar, sir.
Yeah.
Sir, you are the most experienced person in this field. How LSTD and Shujitsu mission should go hand to hand for obtaining good results? Sir, what is your views? Please share with us.
Yeah. I was introduced as Deputy Chief Engineer and Director of High Tech, etc. Actually, I was in Institute Commission as Director SWM for 2.5 years. So, my opinion is that most of our wastewater treatment plants are costly, and most of them go idle after 2 or 3 years, maybe due to lack of money on the part of the local bodies, etc. What I'm interested is what that was presented by Dr. Ratish Menon, that nature-based treatment system. So, if we want a sustainable system, we should definitely go to nature-based treatment system. Since most of the modern methods of water management are costly and not sustainable. Hope that we can manage all the waste aspects naturally and biologically and without much input by using naturally available filters, waste sucking plants like vetiver. Certain wooden planks are also there, which old people know. If we are able to do it, then we can dispose of wastewater within our pores and keep the water table high. And we can free our local bodies from spending much money into this field. And that's what I want to stress, that going to nature-based treatment system is more feasible. Thank you.
Thank you, Anwar sir. Dr. Ramaraju sir,
Yes, sir.
you have immense of experience in both academic and industrial sector in this field. Can you share some of your experience in the implementation in such a way that it will help the Kerala engineers to successfully face the LWM challenges? Sir, please.
Thank you, sir. Thank you. First of all, I have to thank the organizers, the Turtle Smart Task Series, whatever the talks you have arranged. And first of all, I have to congratulate Dr. Ratish, who presented very nicely, bringing out all the technologies which the country is practicing now. There is no much to talk because it is a God's own country. As you all aware, several technologies, specifically the sanitation systems. When you tell about the water is life, sanitation is the way of life. Whatever the technology you take, it may be DVAT system, EcoSan, ventilated improved latrines, VIP, or twin pit latrines, all are originated or started from Kerala. In fact, the government of India first declared open defecation free. The first state is Kerala. So we have to learn from your state. So as per the technology and other things are considered, of course, Kerala has done wonderfully because you don't have any problems like water quality and quantity, no issues as such. As per the technology is considered, you don't have much problems there. Here, if you take our Karnataka, we have several problems. We have water quality problem, water quantity issue, something like that. Because if you take Bangalore itself, Bangalore needs almost 1,900 mld of water, the cities like Bangalore. Whereas the Bangalore water supply and sewerage is supplying almost 1,450 mld, 1,450 mld of water they're supplying. Of course, as you are aware, 20 to 30% losses will be there. Maybe around 900 to 950 mld of water they are supplying to the community. At the same time, they are exploiting the water through groundwater. This is bore wells. Almost 450 mld of water is supplied through bore wells. The people are using their own bore wells and all. The major drawback here is water quality problem and water quality issues, because incrustation of the pipes. So many things are there, breakages, old age pipes. Of course, Bangalore Water Supply and Sewerage Board is taking a lot of, I mean, the water quality monitoring surveillance program, and also they are doing it to their level best. But in fact, in spite of all those things, we are facing several issues. Whereas in Kerala, there is no cases as such, because as you already know, 99% of individual households have their own septic tanks. Septic tank is one of the worldwide accepted technology. Only thing is here, we have to follow either Bureau of Indian Standards or US EPA, United States Environmental Protection Agency guidelines for the construction. As we know, only will involve our masons. Will I come here and construct the septic tanks? We'll simply ask them to construct, because nowhere will take the help of the engineers. If the engineer is used constructed technically, there is no issues as such. But as you already quoted in the Dr. Ratish's presentation, 99% is already covered. Almost all the people, they will be having the household connections. They will be having the septic tanks, on-site sanitation systems. Whereas if you compare like that, Karnataka is not to that level. Maybe if you go to the rural area, we may have to 25 to 30%. That is all. Even whatever the government is talking about, Swachh Bharata, Nirmala Bharata, Abhiyana, all those things which are already practiced in Kerala, specifically they have the advanced, latest technologies like activated sludge process. Of course, it's a common phenomena what we are practicing. It may be trickling filters, again, anaerobic sludge blanket system, UASB, or rotating biological contractors, membrane technologies. All these, of course, whatever the Ratish presented, definitely we have to appreciate. We are also using that technology. One thing I'm very happy to tell at Karnataka level, here I told that 1,440 MLD of water is supplied through government. Of course, other 450 LD from the MLD from the groundwater sources. As you are all aware, 80% of the water will be generated in the wastewater. We are happy to tell that Bangalore Water Supply and Sewerage Board has installed nearly 28 wastewater treatment plants where they are treating 720 MLD of water. That water is recycled or reused for various non-domestic purposes. We are filling the tanks. At the same time, that water is supplied, even tertiary treated water supplied to our international airport also. In that direction, government of Karnataka is also taking a lot of initiatives where we have the both quality and quantity issues. But as already told, God's force country, God's force state don't have such problems. I hope that the things will go smoothly in the days to come. First of all, I have to congratulate the organizers and Ratish and most entire team for giving us the opportunity to deliver the talk. Thank you all, sir. Thank you all.
Thank you very much, sir. Dr. Jyoti Rupa ma'am, you have a lot of experience, academic experience in this sector. You please share your strategies, how the liquid waste management projects in Kerala can effectively done.
Good evening, everybody. Good evening, sir. Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Sir, I would like to take up this topic in two portions. First thing is related to the technologies. The title of the presentation, Ratish sir has elaborately discussed about all these topics. First one is the technologies. Second one is the implementation, how to manage. So when it comes to the latest technologies, whatever sir has mentioned, most of the points, definitely it holds good. Related to the domestic wastewater, basically he was dealing with the domestic wastewater where the biological treatment, the latest technologies, MBBR, RBC, all these things, definitely even in Karnataka state or any other state, definitely they are going ahead, and it has been implemented successfully. And second portion, what was when he says wastewater, I had assumed that he was speaking about the industrial sector also, which specifically he has not mentioned anything about specific industries. But I would like to tell that as an academician, and of course 2.5 to 3 years even I had the industrial experience, I just want to clarify this with respect to Kerala, whatever the scenario, whether the wastewater is being treated, that is industrial wastewater is being treated separately, or it is mixed with the sewage. That one point where as a governance we have to take care. So if it is mixed, then heavy metal concentration also is a problem. which of course it is not being discussed in detail. That aspect, of because I have written down some points when Ritish sir was presenting. So that aspect also definitely we can take care. And the third aspect, what I would like to insist in the technologies. Whatever the technologies he has mentioned, I would like to add one more thing related to the smart city concept. That is, nowadays we are going ahead with the IoT and other whatever the latest technologies. That is the usage of sensors in the treatment plant. So that aspect also the Kerala government can go ahead along with the implementation of the technologies. This is the latest one. So, and we can get the results easily and more effectively using the sensors or IoT. So that is a talk of the town now. Like even the central government or any other government, they are insisting about the smart city concept. So definitely this can be taken care of. So this is related to the technology part. Now coming to the governance, that means say liquid wastewater management. So it can be done in 4 stages. As an academician, if I look at the situation, it can be they'll say that today's children are tomorrow's citizen. So what as a person, as an academician, what I have done as a BOS member also, I have introduced the latest technologies in our syllabus, and we take the UG students for the treatment plant to visit, so that they will get the seriousness of the situation. And tomorrow, if they have any innovative ideas related to the, as I told, IoT or anything related to sensors or something, they can definitely implement and they can suggest the government. So Kerala government can definitely take this into consideration, considering all the UG or PG students also, MTech, if MTech environment courses are there, definitely the students can be taken to the field visit, they can be educated, and the new ideas from them, it can be extracted and implemented in your policies. That is one thing. Second thing is public awareness. As from the lecture from Ritish sir, I have come to know that there's not much of public awareness in the Kerala state. So that also the local government bodies, like how they go ahead with the during election time, how they do publicity or something, so that local government governance, they can take care of publicizing the importance of this treatment and good handling, that is scientific handling of the sewage. Not only with respect to these laying of the sewer lines, etc., and STPs, even within the building, people can be educated how to handle the wastewater effectively. So how to reduce the usage of water supply, how they can reuse it. So people can be educated at the grassroots level. Third one is the governance, that is the involvement of government policies, that is taking into consideration the BIS standards or any other standards. So going ahead, but here I would like to mention, after seeing the presentation, I felt that the first step is the collection of the wastewater when it is coming to the sewage. Anyway, I'm not discussing about the industrial wastewater. Collection is laying the sewer lines. Of course, the septic tanks and other whatever the sir has discussed about the deep trenching and geobags, all this, yes, definitely there are latest technologies. But when it is coming to the quantity, large quantities of wastewater, I feel that STP is the STP or wastewater treatment plant is the best solution. And for that, the basic prerequisite is the laying the sewer lines. But according to his presentation, I came to know that only 3% approximately 3% of it is only being connected through this particular lines. So I feel that the more focus should be given on the scientific collection of the wastewater, using the sewer lines, connecting brand sewers, then laterals you are having. So that part, it is laying on the government, that is the local, whatever the bodies are there. So they have to take care. Of course, when it comes to the funding, definitely it is increasing the funding. I definitely do agree. But one-time investment and going ahead with the hygienic process. So, and I saw in the presentation also 80% of the water bodies are contaminated and so many problems. So it will lead to unhygienic conditions, and definitely when we speak about smart cities, it is contradictory. When I speak with the smart city concept and like 80% of the water bodies are contaminated. So those things, I think the government can definitely take care. And the first step is, I feel that laying the sewer lines is the first step. That is what I have definitely felt. And the last thing is, of course, this talk is very the talk like this, involving the academicians, research institutions, and including the medical sectors, like how the waterborne diseases can affect the health of a human being. So all this involvement of other committees like academicians, research institutions, doctors, health sectors, so combined together, they can definitely work out the integrated part of the treatment systems. Definitely they can work out, because technologies are there, sir. Definitely technologies, number of technologies in the internet, if we see, definitely it is there. And latest one, as I told you, IoT and other sensors, all the technologies are there. But implementing here, when I see the Kerala situation, I felt that implementation part should be more focused. It should be taken care of, like laying the sewer lines and educating people, and from the root level, it has to go ahead. So that is my opinion, sir. Thank you.
Thank you very much, sir, madam. Thank you very much, madam. Let us move to question answer session.
Let me just make a note of the question in the chat box. I think Praveen sir has answered the major question, and the one question remaining is, what are the methods available for disposal of treated sludge? Ratish sir, can you answer this question? What are the methods available for disposal of treated sludge?
Yeah. So the treated sludge is actually a resource that can be utilized as a manure or fertilizer. And depending on the treatment process that we are using, the most popular one is converting that into a compost or a manure. Another one is a biochar. So whatever may be the treatment process, ultimately, in order to complete the sanitation cycle, we have to utilize that as a fertilizer and generate agricultural produce. So that's how it has to be used. It has to be reused as a product.
Thank you, sir. Now, if the participants have any questions, you can unmute and ask the question.
Ajit sir, good evening, sir.
Good evening. Good evening.
Sir, in chat box, I put a question. Can you answer that?
Jiten sir, I could not read that.
Oh.
Okay, sir.
Sir, please.
The question is like, question is from Raju sir. It's like, in Kerala, in my experience, a big amount to be paid to Pollution Control Board to get license for an institutional STP. I think it will adversely affect. Please comment.
Yeah, we have to get the sanction from the Pollution Control Board that they are taking care of the requirement of the STP only. What are the minimum requirement for that particular population? So that the calculation and those any other scientific aspects they are not take care of.
Sir, my question is that they are imposing some big amount as a fees.
Yeah, that is by that is proposed by the government.
Actually, for this executing this type of project, we spend a big amount. In addition to that, we are paying means
they are paying big fees. Yes. Recently, they have raised the fees, I think.
Yeah,
reduce the area and raise the fees.
That is certain percentage of our estimate. If good
correct.
plant is
That's the policy of the government. We are helpless in that matter. That I know. That I know very well.
Okay, thank you, sir.
Okay. Jiten sir, if there is no doubts, means.
So we'll wind up the session. If they have any questions, they can mail us. We'll forward that to the speaker. I believe that there are no other questions. If the participants have any further question, you can mail us so that we will communicate that to the speaker and he'll reply to it. So now we'll wind up the session. Thank you all, especially the speakers and the panel members. Thank you all.